is it important to consider things like welding standards and material costs, but also to get the job done quickly. With Solid Edge, you can accelerate your design with specific tools for frames and welding. Let's take a look. Here we have a pump assembly that needs to be supported by frame design and then finished with detailed weld operations. We'll begin this frame design by developing the supported solid in which the frame pieces can be created from. To reduce clutter, you can first turn off the parts not needed for this task using predefined display configurations. Notice the base solid in our design supports the blue pumps, but we need to add support features for the holding tanks. We can create the features using the information already in the assembly. This protrusion feature provides the options to omit internal loops, which are what we are using here. Not only can frames be created from solid geometry, but also from simple sketches. In this case, we need to add a couple of lines that run below the pumps. Notice how easy we can pick up the center of the bolts from other geometry in the assembly to make sure that our framework is in the correct position. You know, the sketching environment gives you great visual feedback during sketch creation to let you know when the geometry being created is point on, horizontal, and so on. Now, of course, we need a second supporting frame, so we'll create a second line using the same techniques as we did with the first line. Then you can simply drag across them both using the trim tool in the center to trim the sketches not needed away. Once completed, the solid and sketches can be used during frame development to ensure their fit and position within the assembly. The next step is to create the actual frame from this information. Some of the frames have already been created just to save us some time. Now, the bottom frame was created simply from the general solid edges we started with. As we continue our design, you'll see how this works. Now, first, you can add the main framework across the bottom. These are the large pieces that support the entire pump station. Notice as they get created that Solid Edge will automatically trim them back where they meet the outside of the frame. And as we zoom up, you'll see that. Next, we can change the frame selection to C-channel that the pumps will connect to. One advantage to Solid Edge's frames is that you can modify the location of the frame once it's placed. So the first thing we'll do is get these frames created. We'll go ahead and turn off some of the parts so you can see how this is actually going to work. You can adjust the position through either a key point. So if you just select the actual key point, you'll notice it'll give you feedback on the cursor. Or you can simply select a point from the sketch and you're in business. You know, you can also create your own custom frame cross sections from a simple 2D sketch and use them within the frame environment as well. In this case, we'll lift up the frames to meet the pump feet. Now, the benefit of using Solid Edge for frame creation is that the edges of the solid can be used for the frame path, just like the sketches we just used. Notice here, you can easily fence select where you want to create the supporting frames for the tank. If any of the edges need to be removed from the select set, such as the bottom pieces, simply deselect them with the fence like you just saw. Now we can apply the frame piece we want for this area of the design, and Solid Edge will go to work creating the framework for these supports. A big time saver is that you don't have to worry about manually trimming each of the frames to match their other frames in this particular design or in any design. As these frames are created, they will automatically get trimmed back to match up with the actual current design that we have. Also, notice on the top how the corner pieces butt against each other. Options are available for you to select the corner treatment that you need. In this case, we will switch them to mitered corners, and notice how quickly they update. Another issue here is that the tank stands are mounted to the top of the solid, so the frames need to be adjusted downward to be at the same level. Now the tool bar that pops up at the top provides quick access to the changes you need to make without a lot of hassle. Simply identify the cross sections to change, how you want to change it, and watch the top frames, in this case, drop down into the correct position. Notice after we drop the frame height down, the tank stands sit on top of the frame just as they should. The final frame that needs to be created is the cross section on the back where the panel connects. This frame structure needs more strength, and this cross section will help provide that strength. One of the biggest advantages to using Solid Edge for frame design is its automatic recognition of other frames in the design to achieve the proper trimming needed to make everything fit. As we create these frames, also notice that it recognizes that one frame is a solid piece and the other butt up to it. If this is not the result you're looking for, you have the option to edit the end condition and change which piece should be the solid piece. It's that simple. Once we have the frame design we're looking for, we're ready to apply the weld features to our framework. Now, in fact, Solid Edge provides the option to mark this frame assembly as a weldment assembly, or a single unit made up of multiple parts or frames. Once this is done, you have several options for placing weld bead information to your design. Let's take a look at a couple of the most commonly used weld bead options. The first is to place a fillet weld to the frames that support the pumps. And here we're using a 5mm weld bead by just identifying the base set of geometry, the C channels, and then of course the target geometry. Once geometry selection is satisfied, notice how quickly the weld beads are created. In many cases, you may not want to spend the time to create the actual weld beads, but instead just apply a label to the areas where weld beads need to be applied. For this, Solid Edge offers the label weld command, which lets you define what type of weld standard you want to use through this advanced interface. After you've set it up, just as simply at that point you can click on the OK button and identify where you want to apply the label. In this example, we just apply the label weld to the bottom of these posts just to show you how it works. So in just a few minutes, we've created several frame structures to support the pump station components, and then we've seen how easy it is to apply weld information to the design. The last step in the process would be to take our design into the draft environment, where you can develop a detailed drawing as well as a report of the parts used for the support assembly. Notice we can do this directly from within the assembly environment. As you do this, you have the option to select a standard company template. Notice that the assembly automatically is placed on your cursor, ready for placement, so there's no confusion to what gets placed and where. Now, before placement, you have several options on the toolbar to make sure you get what you want easily. After placement, we're ready to begin documenting the design. We can select from any number of standard or custom created parts lists. As the list is placed, associated balloons are added and their location adjusted easily. This list includes things like title, material, quantity, cut length, and even miter cut angles as well. If you need to edit the list, a simple double click and direct changes to the list can be made. Now, you may also want to create another list that gives you total lengths of the components you use, such as this list. Notice the list can be customized also, such as where we can add material to cover rough cut in clearance. Basically just a click and go into the properties, and in this case we'll add 5mm. Easy as that. Once added, the numbers in the list will update to the change. The only thing left to the document is the weld beads that were added in the assembly. Now, Solid Edge provides the tool to extract weld bead information so you can document how this frame needs to be welded together. In both cases, we are getting the information from the design, so we know it is accurate and what the designer is asking for. So you can see how easy it is to design frames using Solid Edge. You also saw the great tools for adding weld details and of course documenting everything in a drawing, most of it automatic, ready for manufacture. Another example of accelerated design.